For centuries, we've stared up at the stars and asked that one huge, huge question. Well, the search for alien life, it's not just sci-fi anymore. Nope, it's a real, focused, scientific investigation. And right now, all eyes are on one very specific and pretty incredible world. Okay, let's dive right in.
I mean, this is it, right? This is the question that pushes us to explore, to build massive telescopes, and to launch rockets into the unknown. It's the ultimate mystery. But what if the answer wasn't light years away in some distant galaxy? What if it was right here, in our own solar system? That's right, NASA is betting big on one of Jupiter's moons, a place called Europa, as the most promising spot to find extraterrestrial life. Why? Because beneath that icy, cracked surface, it's hiding an absolutely incredible secret.
So, to really get why scientists are so hyped about this, we have to look deep beneath the surface. Because Europa, it turns out, isn't just a frozen ball of rock. It's an ocean world.
The scale of this is, well, it's almost impossible to wrap your head around. Data from the old Voyager and Galileo missions basically confirmed it. Europa has a global, saltwater ocean hidden under its ice crust. And get this, scientists estimate it holds more than twice the amount of water of all of Earth's oceans combined. Just let that sink in for a second.
So you're probably asking, how on earth does an ocean stay liquid that far from the sun? Well, the answer is this amazing process called tidal flexing. Basically, Jupiter's massive gravity is constantly pulling and squeezing Europa, like a cosmic stress ball. All that friction generates a ton of internal heat, keeping the moon's core fired up and its enormous ocean in a liquid state. Okay, so a giant ocean is a fantastic start, but it's not quite enough. If you want to find life, you need the right recipe. And it turns out there are three absolutely essential ingredients. According to NASA, life as we know it needs these three things. You've got to have liquid water, which is the perfect medium for chemical reactions to happen. You need a source of energy to kickstart those reactions. And of course, you need chemistry, the actual building blocks, carbon, hydrogen, oxygen, all that good stuff. But here's the crucial thing. Just having those ingredients lying around isn't enough. Think about making tea, right? You can have tea leaves, sugar, and ginger sitting in a pot forever, but nothing's going to happen. You need the water to act as a medium, and you need heat, the energy, to get them all to mix and react and actually become tea. The exact same principle applies to life. And this is where the story gets really, really cool. The best proof we have that life could actually exist on Europa, well, it comes from the deepest, darkest corners of our very own planet. We all kind of grow up with this idea that all life on Earth depends on the sun. But is that really true? The answer is surprisingly no. We don't necessarily need sunlight to live. What we need is energy. And the sun is just one of many places to get it. Sure, most life up here on the surface gets its energy from the sun through photosynthesis. But if you go deep into the ocean, where not a single ray of sunlight can reach, life is absolutely thriving on a totally different power source: geothermal energy. That's heat rising up from the planet's own scorching hot core. This energy blasts out through what are called hydrothermal vents. Think of them as underwater volcanoes. These spew out superheated mineral-rich water, creating these incredible oases of energy in total darkness. And understanding these vents is the absolute key to understanding the potential for life on Europa. This right here, this is the proof of concept. The very first life on our planet didn't start in some sunny, shallow pond. It started in the deep, dark ocean, powered entirely by the planet's internal heat. And since Europa has that same internal heat and a similar kind of ocean, it's totally plausible that the very same process could be happening there, right now. So, we have a target. We have a solid reason to believe life could be there. But how in the world do we actually get there? It's not exactly a weekend trip. In fact, it's one of the most ridiculously complex journeys we've ever tried to pull off. Just to give you a little sense of scale, the distance to Europa is about 1,600 times farther than the distance to our own moon. Let me put it another way. If getting to the moon was like walking to the building next door, getting to Europa is like starting in Mumbai and traveling all the way to Delhi. It's a colossal leap. And that journey, just one way, is going to take 7 years.
7 years of flying through asteroid belts, dealing with crazy gravitational forces, and just the vast emptiness of space. All of it requiring calculations that are just mind-bendingly precise. The mission is called the Europa Clipper, and it's scheduled to launch in October 2024. Now, to get up enough speed to make it out there, it's basically going to play a game of interplanetary pinball. It'll launch from Earth, fly past Mars to get a gravity slingshot, then boomerang all the way back past Earth for another slingshot, and only then will it have enough juice to finally head out towards Jupiter, arriving sometime in 2031. But after that epic 7-year journey across the solar system, the real mission finally begins. The search for life in that dark, alien ocean.
Honestly, the plan sounds like it's straight out of a Hollywood movie. First, the main Clipper satellite will orbit Europa and map everything out. Then, it's going to deploy these things called cryobots, robots literally designed to drill through ice. These bots will use nuclear power to melt their way down through an ice sheet that could be 20 kilometers thick. Once they break through to the ocean, they release 48 little micro-robots to swim out and finally begin the search.
You know, missions like this, they're about so much more than just the science. We're talking about hundreds of the world's most brilliant scientists and engineers from all different countries, all different backgrounds, all coming together to chase what might be just a 1% chance. It's got nothing to do with profit or power. It's just pure, unfiltered human curiosity. And it's that curiosity that's pushing us toward an answer that could literally change everything we know. Just think about that for a second. What will it feel like? What will it mean for us, for all of humanity, if this mission actually succeeds and we finally learn that we are not alone in the universe?